Number one is you give them two functions, g of x and f of x, and they want you to plug in to g of x a negative 2t and plug into f of x negative 2t, and then subtract them, what you get. So let's take this and plug it into g of x. So g of x is a negative 3 times whatever you plug in minus 3, and we're going to plug in a negative 2t. So g of x is going to be, when you multiply that, it's going to be a positive 6t minus 3. And then if we plug into f of x, this right here, f of x is 2 times whatever you plug in minus 3. So they're almost the same thing. When you multiply negative 2t by 2, you're going to get a negative 4t minus 3. So in the red we've got f of x, and then in the black you got g of x, and you're going to take these two answers and you're going to subtract them. But because f of x is two terms, you need to subtract both of them. Don't forget to subtract both of them. So if you minus a negative 4t, that's the same as plus 4t, and if you minus negative 3, that's the same as plus 3. So combine your like terms. A 6t and a 4t is total of 10t, and a negative 3 minus 3 plus 3 cancels out. Number 3 is a composition, and it's the same as number 2. If you write this as it appears in number 2, it's going to be this. First you're going to do h of x plus 2, and then you're going to take g of that. So this is what number 2 looks like. So let's take this x plus 2 and plug it first into h. H says 2 times whatever you plug in, and then when you're all done with that, add 4. So distributive property, you're going to have 2x plus 4 plus 4. So you're going to have 2x plus 8. So now we're going to take this 2x plus 8 and we're going to plug that into g of x. So g of x says almost the same rule. 2 times whatever you plug in, I'm going to plug in 2x plus 8 minus 4 at the end. Distributive property here, 4x plus 16 minus 4. So 4x plus 12 is what we end up with. Number 5, find the inverse. Okay, the inverse is just totally undoing everything. And there's like 4 steps. Step number 1 is to replace f of x with y. Y equals 4 plus x plus 3 plus 1. Then step number 2 is just to change your x and y. Remember, inverse, if you've got a table like this, x, y with negative 2, negative 1, 0, 1, 2, and your outputs are 3, 4, 5, 6, 7, the inverse of that is where you just switch your inputs and your outputs. So the inverse is going to be 3, 4, 5, 6, 7, and the outputs are going to be negative 2, negative 1, 0, 1, and 2. So the inverse is just where you switch your x's and your y's. So in the next step of this, we're going to switch our x, interchange them, your x and your y. So it's going to be x equals 4 divided by y plus 3 plus 1. And now you just undo everything and solve for y. Get y all by itself. So move number 1, let's undo this plus 1. So minus 1 from both sides. And we've got this. I'm going to come up over here. We've got x minus 1 equals 4 divided by y plus 3. Alright. Now, it maybe kind of gets a little tricky. We need to get rid of that y, or we need to get y all by itself, but y right now is on the bottom. And here's where it maybe can get tricky. It's on the bottom with plus 3. So think of that, they're kind of around parentheses. So we need to get rid of both of them. So let's just get rid of the 4. Here's how you get rid of things in the denominator. If I multiply both sides by y plus 3, I'm going to multiply this side by y plus 3, and it's times that. And on the right you can cross cancel, those undo themselves, so on the right you just have 4. On the left you have got y plus 3 times x minus 1, and if I divide both sides by x minus 1, so if I change colors again, if I divide this guy by x minus 1, and if I divide this by x minus 1, that's going to cancel there, and here's what we've got. We've got y plus 3 equals 4 divided by x minus 1, and then all we have to do now is just get rid of that plus 3. So if I subtract 3 from this side and I subtract 3 from this side, my final answer is going to be y equals, I've got a fraction, on top is a 4, on bottom is a x minus 1, and then minus 3. So this, I guess actually that's your inverse, but we need to write it as the inverse. So if we write it with the notation, it's going to be f to the minus 1 of x equals 4 divided by x minus 1 minus 3. So that one was kind of tough, because right here it's kind of hard to get rid of things when they're on the denominator. So if you just times both sides instead of divide both sides, that's how you do it. Okay, number 7. Identify the domain and range and sketch the graph. And maybe the go-to, if you've got to draw a graph, if you're not sure what to do, always just go to a table. Okay, now, because it's the square root, it's going to be a little different. I am looking for these square roots. I'm looking for the square root of 0. I'm looking for the square root of 1. I'm looking for the square root of 4, square root of 9. Because in each case, these are all perfect squares. And the square root of 0, this guy right here is probably the most important, because that is the very smallest square root that can be taken. Because if you go one smaller than that, if you try and take the square root of a negative 1, then you are into a new set of numbers, a set of imaginary numbers. So the square root of 0 is as small as we can go. So I'm going to ask myself, what number plus 4 is going to give me the square root of 0? So what can I plug in for x? What number added to 4 is 0? And the answer is, if I plug in a negative 4, so if I plug in a negative 4 right there, a negative 4 and a positive 4 is 0, and the square root of 0 is just 0. So there's my first dot, left 4 and 0. My next dot, okay, I'm going to go for this guy. What number can I add to 4 and get 1? It's kind of a mental math. What number plus 4 is 1? That number is negative 3. Because when I plug negative 3 in, negative 3 plus 4 is square root of 1, and square root of 1 is just 1. So my next dot is left 3 up 1. Okay, square root of 4. What number plus 4 is 0? And that is mental math, just 0. When I plug in 0 for x, 0 plus 4 is 4. Square root of 4 is a whole number 2. So it goes 0 up 2. And then next, square root of 9. What number plus 4 is 9? That number is 5. So if I input a 5, it's going to give me square root of 9, which is just a 3 whole number. So over 5, up 3. 1, 2, 3. So remember, this is kind of like a parabola, because the opposite of a square is a square root. These two guys are inverse each other. So parabola is going to look like that. The vertex is right here, but we're not going to do the other half. We're just going to do, because every square root, there's two roots. There's a positive and negative root, but we're only going to focus on the positive root. So your graph is going to look like that. The arrow is going to go forever to the right, but the farthest that it goes to the left is right here. It is not going to go any further left than that. So let's talk about the domain. Domain is your x's, your x-axis, left to right. So the domain, to the right it goes all the way to infinity, but to the left it does not go any further than a -4. So I'm going to say x is greater than or equal to a -4, and this is a pretty simple way of writing the domain. X is anything bigger than or equal to 4. The range, okay, the range is the y-axis. The range is up and down, and I'm disregarding this, the other half of it. So the range, if this goes on forever to the right, it's going to slowly rise. So it's going to go all the way to infinity as far as up and down, but down it's not going to go any further than 0. So the y-axis is anything bigger than or equal to 0. And I think that's it. Let's go on to number 9. Number 9. Find the discriminant of each quadratic equation and state the number and type of solutions. Okay, the discriminant from your quadratic equation, x equals -b plus or minus square root b squared minus 4ac all over 2a. The discriminant is this guy right here. He's what's underneath the radical. So to find that, you need to identify your a, your b, and your c. And if you look at this one on number 9, 8r squared minus r minus 17 equals a -8. Let's take this -8 and add it to the other side. So let's add 8 on the right, add 8 on the left, and we're going to have 8r squared minus r, is that minus 9, equals 0. And as soon as they're all on the same side, now you can pick apart your a. Your a is going to be this guy right here, the coefficient of the r squared, so a is 8. B is the coefficient of the r, so that's a -1, and c is a -9. Okay, now you can plug them into your quadratic formula. So x equals -b, and b is a -1, plus or minus the square root of b squared, a -1 times -1 is a +1, minus 4 times a times c. Let me grab a calculator. 4 times 8 is 32, and 32 times a -9 is a -288, all over 2 times a, 16. Okay, now all I care about is this guy right here. So I'm going to ignore the rest, and I'm going to, if I do 1 minus, okay, that's plus. So underneath the square root I have got 289. So I know that I am not going to have imaginary numbers, because this is going to give me a real number. So I'm gonna calculate. I'm gonna go square root of 289, and the square root of 289 is the whole number. That's a perfect square. Square root of 289 is 17. So I've either got two options. It was a whole number, or it was an irrational number, like the square root of 2. Square root of 2 is just some decimal that goes forever. So this is called an irrational number if it's a decimal that goes forever. But if it's a perfect square, we call that a rational number. So that's going to answer the type of solutions. And there are going, because it's going to be plus or minus, there's going to be two rational solutions. That is my answer. You don't need to solve it. You just need to tell me how many and what type. Two rational solutions. 11. Solve this with the quadratic formula. So that's our ABC. I'm going to move this over. Plus 1, plus 1. 6n squared plus 5n plus 1 equals 0. A is 6, B is 5, C is 1. So x equals negative b plus or minus the square root of b squared, 25, minus 4 times a times c is 24, all over 2a, all over 12. Okay, I think this one's going to be pretty fun. So we got a -5, whoops. So yeah, it's -5 plus or minus the square root of 1 all over 12, and this is nice because the square root of 1 is a whole number. Square root of 1 is just 1. So here's what you really have. -5 plus or minus 1 divided by 12. So let's do both of them. Let's do a -5 plus 1 divided by 12. And let's do a -5 minus 1 divided by 12. My two answers are going to be a -4 over 12. So that's the same thing as a -1/3. And a -6 over 12. And that's the same thing as a -1/2. 13. Solve it by factoring. Okay, this is actually easier than the quadratic formula, but let's get everything on the same side. P squared plus 13p plus 40 equals 0. Factoring. This is an addition problem. Let's rewrite it as a multiplication problem. Factoring is just rewriting it, manipulating it. What times what is p squared? P and p. What times what is 40? But when you add, it's 13. So 1 and 40, 2 and 20, 3, 4 and 10, 5 and 8, and I think that's it right there. 5 and 8. 5 plus 8 is going to give you 13. And they are both positive. Plus 5 plus 8. Because they multiply and give you a positive number, and they have to add and give you a positive 13. So now you use your zero product property. This quantity multiplied by this quantity is 0. The only way you can times and get 0 is if you times by a 0. And if p was a -5, that would make that 0. And if p was -8, that would make the other quantity 0. So there's your two options, your two scenarios. 15. Now this is what we've been doing most recently. Kind of have a complex fraction, and there's a lot going on here. Let's first of all recognize that it's a division problem. So you're doing your top divided by the bottom, and whenever you're dividing by fractions, you keep, change, flip. Keep the top, change the division to times, and multiply by the reciprocal. Flip the bottom upside down. Okay, but this top, look at this numerator. And let's clean it up a little bit. Since it is like denominators, it's going to be a piece of cake. But let's work it out maybe like it's problem 16, because 16 does not have like denominators. So the trick is, when you're adding and subtracting and you don't have common denominators, here's what you do. You multiply the bottoms, so that's a 9. And then you cross multiply the tops. That 3 times 4 is going to be 12, and 3 times x squared is 3x squared. So that right there is my top. And I'm going to divide by the bottom. I'm going to times by the reciprocal. 4 over 3. Okay, now multiplication of fractions is pretty easy. All you do is times your tops and times your bottoms. And you can cross simplify, cross cancel, and I'm looking at this 3 on the bottom right, and I'm looking at this 3 on the top left, and this 12 on the top left. So if I divide each of those guys by 3, 12 is going to change to a 4, and it's just going to be 4 plus x squared. The bottom is going to stay a 9, 4 over 1. So I just cross canceled my 12 plus 3x squared and my 3 on the bottom. Okay, now multiply the tops. You need to multiply both terms by 4. So you're going to have a 16 plus 4x squared. On the bottom, just 9 times 1 is 9. And look and see if there's a GCF of 16, 4, and 9. And there's not, so that must be your answer. 17. Okay. Okay, just looking at 17 is awful. It's kind of ugly. Solve each equations. And what's ugly is it's fractions. So hopefully you remember a slick way to get rid of your fractions. Look at the denominators, n squared, n, and n squared. And what's going to make our life easy is the LCM, least common multiple. N squared, n, and n squared. The LCM is n squared. That's a number that each of those can go into. So I am going to multiply this guy by n squared. I'm going to multiply this guy by n squared, and I got to multiply that middle by n squared. And then cross cancel. That's going to cancel that, so you got 1. An n squared on top and an n on bottom. After you cancel the n's, there's going to be 1 left over, so it's going to be 3 times n. And on the right, those cancel, so you just have n minus 4 on the right. And now it's a piece of cake. So whatever you do to one side, you got to do to the other. If you're going to multiply by n squared, you've got to do it on both sides to every term. Now I'm just going to move this over here. Minus 1, minus 1. So I've got 3n equals n minus 5. Minus n, minus n. I'm going to have 2n equals negative 5. Divide by 2, divide by 2. N is looking like it's a fraction, a negative 5 halves. And call it good. 19. Okay, kind of fractions again. Simplify, and this is a multiplication, so piece of cake. All we need to do is multiply the tops and bottoms. But let's see if we can cross cancel anything. And hopefully, if you stare at it, this guy should jump out at you. K squared minus 4k minus 45. Right now I can't cancel anything. But if I were to rewrite this as a multiplication problem, if I were to factor it, I wonder what that would look like. So I'm going to rewrite the left expression, 1 divided by k minus 6. Okay, on the right, I'm trying to see if I can express it some other way. What times what's k squared? That's going to be k and k, and then a minus 45. Okay, because it's negative, one of them's got to be positive, one of them's got to be negative. Positive, negative. 1 times 45, 2, I think 3 will work. 3 and 15, and then 5 and 9. Okay, now you look at the middle term. They've got to add up to give you a negative 4. So we're going to zero in on the 5 and 9. And which one's going to be negative? If I do a 5 and a negative 9, there's your negative 4. So we're going to go k plus 5 and k minus 9. Alright, now because it's just one term on top, because they're separated by times, I can cancel. So this k plus 5 on bottom and this k plus 5 on top cancel out, and that's it. On top, your final answer, you just got a k minus 9, and on bottom you got a k minus 6. 21. Identify the vertex, axis of symmetry, the minimum or maximum value, and then sketch the graph. Okay, the vertex and the axis of symmetry. Hopefully you remember this guy. Negative b divided by 2a, part of our quadratic formula. This right here is going to give us our axis of symmetry. Negative b divided by 2a. So let's pick apart the a is 1, b is negative 8, and c is 15. So negative b is going to be negative 8 divided by 2 times 1. So that's a positive 8 divided by 2. That is 4. So your axis of symmetry is going to be this. It's going to be x is 4. That is your axis of symmetry. So on the x-axis of 4, right there is your line of symmetry. Okay, the rest of it just comes like a lot of other graphs do if we just make a table. but I know I'm going to plug 4 in for x. If I plug 4 in, what is it going to spit out? So let's plug 4 in to this x and to this x. So 4 squared 16, and 4 times 8 is 32, so 16 minus 32, and then that's a negative 16. Add 15 to that, so it's a negative 1. So now let's go over 4 and down 1, and this right here is your vertex. That's the vertex. Okay, let's do a couple more. Let's stay close to this 4. I'm going to plug in, let's plug in 3. So 3 squared is 9. 8 times 3 is 24. 9 minus 24 plus 15 is 0. So over 3 and 0. Then it reflects across that. And let's just do one more. Let's plug in a 2. 2 squared is 4. 8 times 2 is 16. 4 minus 16 plus 15 is going to spit out a 3. So over 2 and up 3. Over 6 and up 3. And your parabola is going to look just like that. So we've done the vertex, axis of symmetry. This question, does that have a minimum or a maximum? And it's talking about your range, your output, your y's. So it opens up, and if these arrows keep going, they're going to go all the way to infinity. But it does not go any lower than right there. So it actually, the maximum is infinity. It does have a minimum. The minimum is, where is that? At negative 1. So that's the minimum, negative 1. 23. Okay, this was a few months ago. Exponents is fraction. I can't remember which is the numerator and what is the denominator. So one of them is going to go here, right here, and the other one is going to go right here. So which one is which? And I always just remember this. 4 to the 1/2 power is actually the same thing as the square root of 4. So that must mean that the 2 goes there and the 1 goes there. So the numerator is going to go right here. I'm going to put the 1 right there. Numerator goes underneath the radical, and the denominator, that's the index of your radical. So 3. And then this guy right here, 7m, is what is underneath. And because they've got 7m in parentheses, let's put our 7m. So our answer is just the cube root of 7m. 25. Alright, let's multiply these guys. And there's a lot of ways you can do it. Maybe just looking at them. First of all, the first thing that jumps out at me is this square root of b squared. A square root and a b squared, they're inverse operations. They cancel each other out. So what's the square root of b squared? It's just b. So I'm going to take that b to the outside, and on both of them, a negative 4 times b to the square root of 10. So I'm going to rewrite it, call that my move number 1. Move number 2, I'm going to multiply these coefficients together. Since it's a times problem, multiply these guys, and you're going to have a positive 20b squared. And then what's underneath the radical? Those can also be multiplied. 6 times 10 is a 60. So on the outside of the squared, I got a 20b squared. Underneath the radical, I got 60, and then I'm done unless I can simplify it. So 60, can you divide that by a perfect square? Can I rewrite this as a times problem? Can I divide 60 by, so you get your calculator, I'm pretty sure 4 is going to go into it. Does 16 go into it? 60 divided by 16. So you just try a couple of those perfect squares, and I think I'm stuck with 4. So I rewrite this as 20b squared times the square root of 4. I know that 4 times 15 is 60. So I rewrite it as the product of two radicals, and I do that because this right here, square root of 4 is a whole number, that's 2. So I'm going to have 2 times my 20, that's going to give me a 40b squared, and underneath you're just stuck with square root of 15. 27, 3 divided by 3 times the square root of 5. Alright. Sweet, you can cancel the 3's. 3 on top and 3 on bottom, so you're left with 1 over square root of 5, and then there's just the rule. You can't have any radicals in the denominator. So you multiply this by some fancy creative 1. And the 1 is square root of 5 over square root of 5. Whatever that radical is, that's what you're going to multiply by. On top, 1 times the square root of 5 is just square root of 5, but on bottom, square root of 5 times square root of 5 is always just going to be 5. Because if you times them together, that's going to be square root of 25, and square root of 25 is a whole number 5. 29 looks just like a subtraction problem, but we got imaginary numbers. Piece of cake. Take the negative, distribute it to both of them, so it's going to be plus 3 and plus 2i, and then 8 minus 4i. Just combine your like terms. 8 plus 3 is 11, negative 4i plus 2i is negative 2i. Done. That's your answer. 31, just like 27. I think we're done, but you cannot, just like you can't have a radical on the bottom, you can't have imaginaries on the bottom. So you're going to times it by a fancy 1, and the fancy 1 is going to be the conjugate of 5 minus 8i, which is 5 plus 8i. Multiply both the top and bottom by 5 plus 8i. On the top, you're going to have 5 times 3i, distributive property, 15i. And then 8 times 3 is 24. I times I is I squared. But I squared is, that's going to get rid of our imaginary, and that's going to take us to a whole number. And I squared is just your negative 1. So this is 15i plus 24 times the negative 1. So we just got 15i minus 24. So that's what we got on top. Now let's figure out our denominator. Do the distributive property. 5 times 5 is 25. 5 plus 8i is 40i. And then a negative 8i plus 5 is minus 40i, and that's why we do it, because that cancels. And a negative 8i times 8i is a negative 64i squared, and that I squared again is going to give us a whole number, or an integer actually. I squared is the same thing as a negative 1, so you really got a negative 64 times a negative 1. So you have got 25 and a 64, and if you add them together, you're going to have in your denominator, you're just going to have 89. Okay, and that's your answer, unless 15, 24, and 89 can all be divided by a common factor. 3 goes into 15 and 24, but 3 goes into 90, so it can't go into 89. So that's it. I think you're done.